Hey guys, I want to start with the worksheet you got at the end of class yesterday and kind of explain a couple things and use that to to learn the next thing basically. So um, I've got filled out here the R and the theta for each of these first two numbers in each table. Hopefully you understand where those came from. It's just from, R is the square root of a squared plus b squared. It's just magnitude, same thing we've been doing. Theta, of course, is tan inverse of the imaginary over the real because it's y over x. And then, thinking about what quadrant it's in. Some of these you don't even need to do tan inverse, right? If you know it's on the axis. So for instance, the number I is just straight up, so you know it's 90 degrees. You don't need to use tan inverse to figure that out. Right here, -2, we know that's to the left 2 units. It should be right on the x-axis. That's 180 degrees. So it's okay to use the common sense a little bit for this stuff. So the real investigation is what happens when I multiply two complex numbers together. So notice this third row, 1 plus I times I, is the product of these two values we started with. If I did this using like old algebra skills, I would distribute the I and I would get 1 times I is I, and I times I is I squared. And I squared we know is -1. If you don't know that, it's just because, remember, I is the square root of -1, so obviously if I square a square root, the square root goes away. So in other words, this number we're dealing with is -1 plus I. Okay, so if I found that R, it would be square root of 1 plus 1 is square root of 2. We know this is in the second quadrant, left 1, up 1, so we have a 45-degree angle, but subtract that from 180 and we get 135 degrees. I know I'm talking a little bit fast, sorry guys. I want to just kind of leave that there, and we're going to come back and investigate what pattern we're seeing here. Okay, so again, when we're looking at number 2, hopefully these two things are not too difficult. If I multiply -2 and 3i, I would get -6i. Think about where that would be on the graph. It would be straight down 6 units. So what's the magnitude? Obviously it's 6. But what's the direction? It's down, so we're going around 90, 180, 270 degrees. Okay. And this last one down here at the bottom, this 1 plus I times 1 minus I, we'd have to FOIL. So I would get 1 plus I minus I, whoops, excuse me, and then minus I squared. So the plus I and the minus I cancel. Again, I squared is -1, so we're getting 1 minus -1, which is 2. So it's just the number 2. What's the magnitude of that? Obviously it's 2. Where is it located? It's 0 degrees. It's straight over to the right 2 units. So what am I wanting for you to recognize? Well, first I want to see the pattern between the R values of each of these. So when I multiplied this top number, we multiplied 2, 45 degrees by 1, 90 degrees. The R value, square root of 2 and 1, if I multiply those together, we get square root of 2. Okay. For the second example, if I multiply 2 times 3, we get 6. If I multiply root 2 times root 2 in this third example, square root of 2 times square root of 2 equals 2. Okay, so this pattern we're recognizing, hopefully, is that when you multiply two complex numbers, all you have to do to find the R is multiply the R values of the two numbers. Okay, again, so what we're trying to do is create a shortcut for when we have numbers in trig form, how we multiply them together. So I don't have to do all this terrible conversion of I squared and foiling and all this other stuff. Trig form makes it much simpler. Okay, so the bottom line is all we have to do is multiply the R values together. We'll formalize this in just a second. Okay, what sort of pattern do we see with the thetas? Okay, well, the thetas, I have 45 degrees, I have 90 degrees. When I add those together, we get 135 degrees. If I add 180 to 90, we get 270. If I add 45 to 315, we don't get 0. What's 45 plus 315? Well, we actually get 360 degrees. Well, why does this say 0 then? Well, because 0 degrees and 360 degrees is the same location. So if I had written 2 comma 360, we would still be right technically. Okay, so the moral of the story is we get to add the theta values together and multiply the r's together. So let's look real quickly at the back. Flip this thing over for a second. Look at the back of your worksheet. So I want to focus on this rule right here. So we're looking at how do we multiply two things in trig form, right? Again, if I had them in standard form, how would I have to multiply them together? I have to FOIL, and that can be a pain, and then we have to deal with the I squared, and then we still have to convert it to trig form at the end. So what this whole big nasty looking thing says, this formula, says if I have one in trig form times another in trig form, then all I have to do is, what does this say? Multiply R1 times R2, right? That just means multiply by the two r's, and that will give you the new r. And what value of theta do I get? I get whatever value you get by adding the theta values from the other two separately. So pretty straightforward. Let's look at a couple examples. All right, so here's a quick example. Here's a quick example. So we're going to multiply these two complex numbers in trig form. The process is real simple, right? Here, my first complex number has an r of 3 and a theta of 135 degrees. My second complex number has an r of 4 and a theta of 60 degrees. Okay, so what our rule just says is if I want to multiply these two things together, all we have to do to find the new r is 3 times 4, because those are my old r's, so I guess I could have labeled this, right? R1 is 3 and R2 is 4. And 3 times 4 is 12. And theta 1 is 135, theta 2 is 60. So my new theta is just 135 plus 60, which is 195. So what's our answer when I multiply this first number by this second number? I just get 12 times cosine of 195 plus I times sine of 195. Done. Easy. The end. Okay, so let's try another one. Maybe you do this one on your own. Okay, so why don't you just pause it right now if you want. I don't feel like I'm going to sit here and wait for you. So you pause it, try this problem. I'm going to go ahead and keep going. So again, all we need to do is multiply R1, which is 5, times R2, which is 7, and get 35. And then add theta 1 to theta 2, which is 310. And it's that simple. So what can I do to make this harder? I'm sure there's something. Well, what I can do to make it harder is give you a number in standard form, but tell you to find the product in trig form. Okay, so maybe I give you a problem like multiply negative 3 minus 3i times, let's say, square root of 3 minus I. Okay, so how do I multiply these things together? Well, again, we can FOIL and do all that, but I want it to be in trig form in my final answer. So what should you do? You should convert each of these separately. So I'm going to take this and find r first. So the square root of 3 squared plus 3 squared is the square root of 18. My theta, we notice that these are the same value, so I should get 45 degrees. You can do tan inverse if you don't trust me. But again, since I'm in the third quadrant, I need to add that 45 to 180. So we get 225. Here, our r would be the square root of square root of 3 squared plus 1 squared. It's kind of funky, so if you don't get that, ask Miss Jennifer real quickly, or Miss Mary. I can't remember who's in here. Square root of 3 squared is 3, plus 1 is 4. The square root of 4 is 2, so we get an r of 2. And our theta here is, if you want to do tan inverse of 1 divided by square root of 3, or negative 1, I should say. You can do that. You can also maybe recognize that we have square root of 3 and 1. It's a special right triangle. So what we should be getting is is, well, negative 30 degrees, but we know better than that. We'll do 360 minus 30 and turn it into 330 degrees. So what we've got now is we know if I wrote this in polar form, I would have root 18 comma 225 times 2 comma 330. You can write all the cosine and the sine crap if you want, but let's just leave it like this. So all I have to do is multiply my r's, which is 2 root 18. And then, well, here I go. I'm already writing in trig form, so whatever. And then add my thetas. So that would be 555 degrees. So there you go. Now, technically, I would like us to simplify this. Root 18 could be written as 3 root 2, so I could write it as 6 root 2. And we also are going to leave our final answers between 0 and 360, so I could subtract 555 minus 360, and that gives us 195 degrees. So that would maybe be an easier way to write it, so we know where that's actually located, right? So if I wanted to graph this or something, right, I would say, okay, 195, that's a little more than 180, that's over here, third quadrant, with a 15-degree reference angle. 6 root 2, maybe you don't know what that is. You could plug that in, 6 times 1.41 or whatever. But the bottom line is, if we knew what the R was, if it was a better number, we could plot that. It's about 8.5 or so, 8.48. So we know it should be located around here. 8.5 away, that's my R, and 195-degree rotation is where we would land. So I want this to go too much further or longer, but I do want to just briefly mention what happens if we have division right here in the middle of the page. Division, we already know. Division is the opposite of multiplication. So if in multiplication we add the r's, we multiply the r's, okay, then it would make sense in division that we divide the r's, right? In multiplication, we take the thetas, theta 1 and theta 2, and we add them up. We add the thetas. Well, what are we going to do in division? The opposite, right? So I'm going to take theta 1 and theta 2, and I'm going to subtract them. Order matters because it should matter in division and subtraction. We know it does. So we'll do one quick example of this because I don't think I need to do a bunch of them, and then I'll be done. Okay, so let's say we have an example here, 18 cosine 270 plus I sine 270 divided by 3 cosine 150 plus I sine 150. Again, this is one of the easier things you'll be asked to do this whole year. All I have to do is do 18 divided by 3, that's 6. What do I do to my thetas? Well, theta 1 up here is 270. Theta 2 down here is 150. And so all I have to do is 270 minus 150, which we know is 120. And that's our new theta. Okay, so again, 120. So there's my answer. Again, if we wanted to convert this to rectangular form, I could distribute 6 times cosine of 120, which again, that's a unit circle value. Cosine of 120 is negative 1/2, so I would get negative 3. And then 6 times sine of 120, sine of 120 is square root of 3 over 2. So times I, so I would get negative 3 plus 3 root 3 times I, right? So this is equivalent. This is the standard rectangular form. This up here is the trig form, same values. If you wanted to prove that this really works, and I know you don't care, but I'm going to string this out for one more minute. Cosine 270, remember, that 270 would be down here. So my original number, 18 cos 270, that's actually the number negative 18i. 3 cosine 150 would be up here. I'm already regretting this, actually. I'm gonna be done with this. Forget it. I don't have to prove it. You don't want to, and I don't want to either. So you go ahead and work on this worksheet, and I'll see you guys on Monday. Thanks for paying attention. Hopefully you were paying attention.